Today, let's try to also discuss about these concepts from the basics. Since you have a lot of experience, you write this book implementing SLOs. But first of all, what is the definition of service and reliability? Because some people actually use these terms interchangeably, so many different variations. Maybe let's start from there.
Yeah, absolutely. Service is actually not difficult to define because you probably already know. It's what the word service just means. One of my favorite examples is that I've drawn so much of my experience and so much of why I love SLOs is because I used to be a server, like server in a restaurant. I provided a service for people, which was to take their orders and bring them food. A computer server is not very much different. It is a thing that takes your requests and responds to it correctly. It's very similar in concept. That's what a computer service is. Computer service is something that listens to a request from something and responds to it appropriately. That, I think, is the best way to think about it. Instead of trying to define exactly what it means at a technological level, because I don't think that's important. To some teams, it is important to think of their service as a pod running in Kubernetes, or a series of pods, or a Docker container somewhere, or a binary running on a virtual machine, or a piece of hardware even, or networking gear. Those provide services as well, and those don't fit any of those previous definitions. For some people, the service they care about is the retail website. You go to a place to buy a pair of socks. Some people at that company just care about that entire website, even though it might be composed of 80 individual tiny microservices. Can really be defined as anything that does something for someone else. I don't think we have to say, okay, that's a service because it is a set of pods deployed via a single deployment on Kubernetes, whatever. This isn't a service because it's a user journey. No. A service, you can think of it holistically. You can think of it philosophically. It's something that does something for. And that leads us right into what I think the correct definition of reliability is, because people often conflate it with availability, but they're very different things. Because a service can be available and not be reliable. Reliability is an old term. Reliability engineering even goes back to the 1940s. It's not a concept unique to SRE or Google or tech or computers. What reliability really means is the system performing how it was defined to perform? For computer services, that basically means, is it doing what it needs to be doing? If we are cool with the concept of a service being a thing that does something for someone else, then reliability is that thing doing the thing it's supposed to be doing? The reason I always try to steer people away from just thinking about it as being like availability is because you can be very available and still be doing a bad job. That example of the retail website where you just need to buy a pair of socks. Well, maybe you can log into the website and it's very quick and you can search and you get 10,000 results for socks and they have every color and every size and everything you ever wanted. But then when you go to checkout, you can't. That's not being reliable, even if that service is being available to you at the time. So a service is anything that's doing something for something else. And reliability means, are you doing that well enough?
Thanks for explaining this. It's very, very simple. I think everyone here could understand that. Really, as part of the foundation, right? When you understand what is service, what is reliability, the next few things will become easier. But before we go into more SRE, reliability and all that, I saw one section in your book where you mentioned about service truths. I think this is an interesting concept for me. Would you be able to share probably what do you mean by these service truths and what are those?
Sure. So I personally believe that there are three things that are true about any service. One is that reliability is its most important feature. If your service is not being reliable, it's not doing much. As we just said, if we're defining reliability as, are you doing what you're supposed to be doing? Well, then it kind of follows. If you're not being reliable, you're not doing what you're supposed to be doing. So you always have to be thinking about reliability first. The second truth is that you don't get to decide what your reliability is. I don't care what your measurements say. I don't care what your logs say, what your metrics say. I don't care if you have 1 million healthy pods all reporting up. If your customers, if your users, anyone that depends on you thinks you're being unreliable, you are. If you're not meeting the needs of your users, you're not being reliable. So you need to take their perspective into account. And then the third service truth is that nothing is ever 100%, so don't aim for it. This is just a truth of the world. Outside of pure mathematical constructs, nothing's ever 100%. Things fail, failures occur. It turns out that people are actually fine with failure as long as failure doesn't happen too often. The third truth is just don't aim for 100% because that's a fool's errand. So instead, pick a more reasonable target. Understand what reliable means, understand that someone else determines what reliable means, understand that reliability is the most important part of your service, and then make sure you're only trying to be reliable enough, like an achievable amount, something that works for both you and the people that depend on you.
As you can tell, these are the fundamental understandings. So let me try to reiterate. The first is that reliability is the most important attributes or characteristics of your system. No matter how your system has so many features or functional requirements, but if it doesn't perform reliably, that's probably not a good service. And the other one is you don't define your reliability, but users do it for you on behalf. So when they use your system, they will tell you if your system is reliable or not. And the last one, nothing is 100%. Don't ever try to achieve that because people are okay with failures as long as it's not failing frequently. Let's go back to the more deep dive definition about SLI, SLOs, and all that. So you have this concept of reliability stack. Maybe let's start from there. What are in the stack? How do you define them and how they work with each other?
Sure. So you have three primary components of what I call the reliability stack. This is what people really often refer to when they're saying SLOs. When they often use the term SLOs, they really mean a few different things. First is SLIs, or service level indicators. Service level indicators are measurements. They're bits of telemetry about your system that tell you, is it doing what it's supposed to be doing? And again, this should be from your user's perspective as close as you can get, at least. Then next you have SLOs, or service level objectives. And service level objectives are just targets for how often you want your SLI to be true. So if your SLI is able to tell you, yes, we're currently meeting the expectations of our users, or it's able to tell you, oh, we're currently not meeting the expectations of our users, you're now able to inform a ratio. Good events over total events equals a ratio equals some kind of percentage. Your SLO is just a target for what you want that percentage to be. So you can pick something more reasonable. So we just talked about 100% is impossible. No one ever hits that anyway. So you can say something like, we'll go back to the sock buying scenario. We may as well use it all night. Why not? If you can't check out when you try to buy socks, that's not good. But it's okay if that only happens 1 in 100 times. Because you try to check out and it doesn't work. What are you going to do? Probably just going to click again. And as long as it works the next time, fine. So maybe you only have to make sure that sock checkout works 99% of the time. It lets you pick a target that's realistic, that accommodates failure, that makes sure you're not spending too much money and trying to aim for something you can't. And then finally, at the top of the reliability stack, you have error budgets. Error budgets are just a way of thinking about how your SLO has performed over a period of time. An error budget often takes into account a time window that's often fairly large, generally anywhere from a week to 28 days to 30 days, sometimes even a whole quarter. The idea is your error budget is that other side of the percentage. So if you say sock checkout should work 99% of the time, what you're also saying is 1% of the time sock checkout is allowed to fail. Your error budget is that 1%. Your error budget measures, are we failing more often or the right amount? And so your error budget lets you think about things over periods of time. Over the last 30 days, what percentage of the time have we failed? And is that helping us meet our SLO targets? Are we exceeding it? Your error budget, it's worded that way because a budget is something you can spend. And an error budget is exactly that. We're allowing ourselves this 1% or whatever you've defined for your own service course. But in our continuing example, you have this 1% of checkouts are not allowed to work. What amount of that have you spent over time? And that then helps you make better decisions about where you need to focus your attention.
Thanks for mentioning about this budget term because it is that consciously defined. It's not something that someone just picked, but it's actually something that can be spent. Errors is expected sometimes, but it also can be spent.